Hello and welcome to another video. In this video, we will be looking at the transfer function of an electrical system. What are poles and zeros of a transfer function and how it will be useful. So to begin, we have seen the derivation, the differential equation derivation of this electrical network with resistor, an inductor and a capacitor in series. So the input is U1 and the output is the voltage across the capacitor. The differential equation is VI equal to LC d square UC by dt plus RC duC by dt plus UC, where UC is the voltage across the capacitor and VI or UI. So it is given here as UI, so I'll replace it as UI. UI is the input voltage and UC is the output voltage. So this differential equation gives the relation between the input and output. Now this derivation was explained in the previous videos. Now we will see how Laplace transform helps us in identifying the transfer function of the system. Now taking Laplace on both sides, we get Ui of s equal to LC s square UC of s plus RC UC of s plus UC of s. Now after substituting the values of resistor, inductor and capacitor, we will get, after substituting the resistor, inductance and capacitance value, we will get s square plus 0.5s plus 1 into UC of s. Now the ratio of the output UC of s divided by the input Laplace transform UI of s is equal to 1 by 0.5s plus 1. So this is the transfer function of this electrical network, which gives us the relation between the output UC of s and the input UI of s. Next, we will check poles and zeros of a transfer function. This is an important concept. Poles, the values of the Laplace transform variable s that cause the transfer function to become infinite. Those are the poles of the transfer function. That is the roots of the denominator in a transfer function. Zeros of a transfer function are nothing but the value of the Laplace transform variable s that causes the transfer function to become zero. Those are the roots of the numerator. Now we will see an example. The s plus 2 by s plus 5. The pole of the transfer function is minus 5 because the value of minus 5 will make this transfer function value to infinite. And the zero of this transfer function is minus 2 because the value of minus 2, s equal to minus 2, will make the value of the entire transfer function as 0. Those are the pole and zero of the transfer function. Now suppose you are applying a unit step input to this system, s plus 2 by s plus 5, and you are getting some output. We will classify, you will identify what is a forced and what is a natural response of the system. So to calculate y of s, we will just multiply 1 by s and s plus 2 by s plus 5 and take the partial fraction expansion and identify y of t by taking the inverse Laplace transform. Now our system transfer function is s plus 2 by s plus 5 and we are getting a unit step input 1 by s. To get the output, we will multiply g of s, r of s. So 1 by s into s plus 2 by s plus 5. By partial fraction expansion, we will get 2 by 5 s plus 3 by 5 s plus 5. By taking inverse Laplace transform, we will get y of t equal to 2 by 5 plus 3 by 5 e raised to minus 5t. So this 1 by 5 is the input applied on the system. So this causes this output. So this is the forced response on the system, forced response of the system. And this is the natural response of the system. This is due to the poles of the system. So this pole s plus 5, so s equal to minus 5. So that causes this term e raised to minus 5t. So that is the natural response of the system. So this is due to the application of the input. This is due to the system poles. So this is the forced response of the system. This is the natural response of the system. So in the second example, whenever you apply, this is the transfer function, whenever you apply unit step input to that transfer function, and you expand by partial fraction expansion, we have K1, K2, K3, and K4. So after finding those values, you can substitute it here. But what we need to see here is that this input 1 by S, that causes this K1, which is the forced response of the system. And this part, which is caused to the poles of the system, will contribute to the natural response of the system. So these are the natural response of the system. Similarly, whenever you apply unit step input to this transfer function and you expand it a by s plus b by s plus 1 plus c by s plus 7 plus d by s plus 8 plus e by s plus 10, you find out the values of a, b, c, d, e to take the inverse Laplace transform. And this a by s will contribute this term. So this is the forced response. It is due to the step input that we are giving to the system. And the other part is due to the poles of the system. So those contribute to the natural response of the system. So this is how we identify the forced response and the natural response of a system. We apply step input to the transfer function and then do this partial fraction expansion and find the forced and natural response of the system. Thank you.